All right, example 2, something a little bit different. Determine the exponential function corresponding to each graph, then use the function to find the unknown. All graphs in this example have the form y equals b exponent x. Now that is really important for this. It would be much more difficult if we didn't know it was this form already. We might need some other information or to do a lot more work. And what this says is that there has been no shifts of the graph or stretches, which I'm sure you're tired of hearing those words at this point. But yes, at this point, we don't have any stretches or translations. That makes life a lot easier. What I'm looking for is what happens as x increases by 1. Now we could make a table. I think that's a little bit overdone. I just want to see as x increases by 1, what's happening to y. Okay, so I have these points right here. So from 2 to 3 are my x values. Perfect. So I'm going to look what happens to those y values. So I go from 16 to 64. Now I know this is some type of multiplication, 16 times something is 64. Now yeah, in this case, maybe more obvious, it's times 4. But what if it wasn't so 64? And I would divide that by 16, which gets me 4. Okay, perfect. So therefore, my b value is 4. So that means I have this equation, y equals 4 to the power of x. Now that's only the first part. It does ask us to do the n as well. So we're going to let x equals -2, which means that our n value is equal to 4 to the power of -2. So we can reciprocate the base, so it becomes 1/4 squared, and we find out that 1/4 squared is 1/16. So there we go. Question is done. Let's move on to a very similar question, except for now we have some fractions in there, making it a little bit tougher, but we're still looking for the same thing. We want to find 2 points where it's going up by 1, or x is going up by 1. So here we have an x is 2, here an x is 3. Perfect. So let's take a look at what's happening to those y values in here then. So when x is 2, we have 9/4, and as x increases by 1, we get 27/8. So we want to know what happened to get from 9/4 to 27/8. So again, it's going to be some kind of multiplication. Well, we got to figure that out. Maybe you can see what it is already, but if you can't, you go 27 divided by 8 divided by 9/4. We're going to reciprocate the second fraction. So that's going to be times 4/9. Now I'm not going to multiply this out because we have some common factors of 4 here. That'll make life a little easier. And common factor of 9 here. Okay, so 3 times 1 is 3. 2 times 1 is 2. Okay, so we actually have to times by 3/2. So therefore, we know b is equal to 3/2. That means that our equation is actually y equals 3/2. Make sure this isn't brackets, to the power of x. We're not done. We need to let x equal, in this case, -3. So we're going to have n equals 3/2 to the power of -3. So I'm going to reciprocate the base. So it becomes 2/3 all to the power of 3. And 2 cubed is 8. And 3 cubed is 27. So therefore n is 27. A very similar example for the next two, except for this time we have decaying graphs instead of growing graphs. So determine the exponential function corresponding to each graph, then use the function to find the unknown. All graphs in this example have the form y equals b exponent x. All right, so we're still looking for, as x increases by 1, what happens to that y value? So I find a -3 and -2 points. Perfect, they're 1 apart. Makes my life a little easier. We're looking for at these y values then. So we go from 125 to 25. Meaning that 125 times something gets me 25. Well, I need to figure out what that is. 25 divided by 125. We simplify this, we get 1/5. Okay, so that means 125 times 1/5 is 25. So therefore, I know that my base is 1/5, and I know that we have this exponential equation of y equals 1/5, again in brackets, the power of x. For our second part then, we need to figure out what n is. So that means we're going to let x equal 1, and we'll have n equals 1/5 to the power of 1. Well, that's nice and easy, so we just get 1/5. Let's take a look at one more graph then. So again, we're looking for as x increases by 1, what is that to figure out what that base is. So we have -3 to -2. Perfect. We have an increase of 1. So we're going to look at what's happening to the heights then at those values. So we have 64/27, and it goes to 16/9. Now this looks way more complicated. So we know 64/27 times something gets me 16/9. Well, this is where that division is going to make life a little bit easier. So 16/9 divided by 64/27. We're going to reciprocate the second fraction. So we get 27/64. Now we have some common factors here of 9. So this becomes 3. That becomes 1. Common factor of 16. So this becomes 4 and 1. So we find out, okay, that's 3/4. So therefore, we have our b is 3/4, and we have this exponential equation of y equals 3/4 in brackets the power of x. We're not done though. We want to find out what this missing n value is. So we're going to let x equal 3 then, and we're going to let y is actually n in our case. So we have 3/4 to the power of 3, and 3 cubed is 9, and 4 cubed is 64.